Hello and welcome. In this video, we're going to look at the current divider equation. So the current divider equation is what we expect our current to do, right? It's going to identify KCl's current division that is associated with when our resistors equal or are smaller or are larger. We expect the current to be inverse of those. So a small resistance gets us a large current. A large resistance gets us a small current. Right? And to identify that, we can do the same thing that we did for our voltage division in series, but now we're going to do it for a parallel connection. So for parallel components of different values, the current will split based off of this ratio, and we're going to flip the ratio over. This time we're going to say total resistance on top and branch resistance on bottom. Right? Our voltage divider equation did the opposite. We put our voltage that we put the resistance we wanted on top and the resistance total on bottom. So this is going to be backwards from that voltage divider equation. And it's going to give us our want current is equal to the total resistance divided by the resistance that we want to know the current through multiplied by our total current. We could derive this too. We can say that let's derive down from I1. We know that Ohm's law says that's voltage divided by resistance. Specifically, if we're looking for I1, we have to use R1 and our voltage source because our source voltage is shared among all of our branch currents. And if we do that one more time, we could say, well, what if we don't want to use Vs? What if we want to break Vs out of this equation? We can say that Ohm's law says the voltage is equal to current times resistance, so I times R, and specifically, since we're looking for the source voltage, we want to know the total current and the total resistance. And so when we plug this back in together, we end up with this equation up here. We end up saying that we have IT multiplied by RT divided by R1. And all we did was pull this one off to the side. That way we get this ratio out. And we end up with RT divided by R1 multiplied by our total current. And that's going to give us the current through that one branch that we're looking for. Okay, let us know if you have any questions.